Leather begins long before it reaches a factory. The story starts in rural livestock regions, where animals such as donkeys have historically served as working companions for farming and transport. After the animal's life cycle ends, its hide becomes a valuable natural resource. Rather than allowing this tough outer skin to decompose, industries transform it into durable leather materials used for clothing, footwear, and other goods. What makes animal hide so valuable is its internal structure. Beneath the surface lies the dermis layer, a dense network of collagen fibers. These natural protein fibers are incredibly strong and flexible. When properly preserved and chemically stabilized, this collagen matrix becomes leather, one of the most durable natural materials humans have ever used. Once hides are removed, they must be handled quickly. Fresh hides begin decomposing within hours because bacteria naturally break down proteins in warm conditions. Without preservation, the collagen fibers would weaken, making the material unsuitable for leather production. To stop this biological decay, hides are preserved with salt. The salt draws moisture out of the skin through a process called osmosis. By removing water, bacterial growth slows dramatically. This simple preservation technique has been used for centuries and remains one of the most reliable ways to stabilize hides before tanning. After salting, the hides are folded and compressed into dense bundles. This reduces space during transport and protects the material from contamination. At this stage, the hides are no longer biological waste. They are industrial raw materials entering a global supply chain. From collection points, the preserved hides travel to specialized tanneries. These facilities are designed to convert fragile biological tissue into stable leather. The transformation requires chemistry, engineering, and careful environmental control. This is where the real transformation begins. Inside these massive facilities, raw hides will undergo dozens of mechanical and chemical treatments. Over the next several stages, the collagen fibers will be cleaned, stabilized, strengthened, and eventually turned into high-performance leather ready for manufacturing. But before tanning can begin, the hides must first be cleaned, softened, and prepared. In the next stage, powerful industrial drums and chemical baths will remove hair, fat, and impurities, preparing the collagen structure for the complex science of tanning. When preserved hides arrive at the tannery, they are stiff, dry, and heavily coated with salt. This salt protected the hides during transport by preventing bacterial growth, but before any chemical processing can begin, it must first be removed. The first step is rehydration. Inside the tannery, workers open the tightly packed bundles and place the hides onto conveyor systems that carry them toward large soaking tanks. These tanks are filled with carefully controlled water solutions designed to slowly restore moisture to the skin. During preservation, hides can lose nearly half of their natural water content. Without restoring this moisture, the collagen fibers inside the skin would remain rigid and fragile, making them difficult to process in later stages. To solve this, the hides are placed inside massive, rotating soaking drums. As the drums slowly turn, water flows around the hides, washing away salt crystals, dirt, and blood residues left from earlier handling. Sometimes, mild cleaning agents are added to the water. These help dissolve fats and loosen trapped debris from deep within the skin's fiber structure. This washing stage is extremely important. If impurities remain inside the hide, they can interfere with later chemical reactions during tanning and lead to weak or uneven leather. Over several hours of washing and tumbling, the hides gradually soften and return to a flexible state. By the end of this process, the once rigid, salted skins are fully rehydrated, clean, and ready for the next transformation. Now, the hides can move forward to one of the most critical chemical treatments in leather production, the liming stage, where hair and unwanted proteins are removed from the skin. After the hides have been thoroughly washed and rehydrated, they move into one of the most important chemical stages of leather production, liming. At this point, the hides still contain hair, epidermal layers, and several unwanted proteins that must be removed before the material can be transformed into durable leather. To begin this process, technicians prepare a solution primarily made of lime or calcium hydroxide, often combined with small amounts of sulfide compounds. These chemicals are designed to break down the structures that hold hair and outer skin layers in place. The hides are loaded into large rotating drums filled with this alkaline solution. As the drums slowly turn, the hides tumble through the liquid, allowing the chemicals to penetrate deep into the skin's structure. Inside the hide, an important transformation begins. The alkaline environment causes the collagen fiber network to swell. This swelling opens the dense fiber structure, allowing chemicals to move deeper into the skin. At the same time, the sulfide compounds weaken the keratin proteins that form the hair. Over several hours, the hair follicles loosen and detach from the hide surface. Once the chemical reaction has completed, the hides are removed from the drum and pass through specialized de-hairing machines. These machines use rotating rollers and scraping blades to gently remove the loosened hair and remaining outer tissue. What remains is the true structural layer of the hide, composed mostly of collagen fibers. This is the layer that will eventually become leather. By eliminating hair, fats, and unnecessary proteins, the liming stage prepares the hide for further mechanical processing and chemical stabilization. The material is now cleaner, more flexible, and chemically opened, ready for the next stage, where excess tissue and thickness will be precisely removed during the fleshing and slitting process. After the liming process removes the hair and loosens unwanted proteins, the hides are ready for the next mechanical stage of leather production, fleshing and slitting. Even though the outer hair layer has been removed, the inner side of the hide still contains layers of fat, connective tissue, and muscle residue. These materials must be carefully removed to expose the pure collagen structure that forms the foundation of leather. To accomplish this, the hides are fed into large industrial fleshing machines. Inside these machines, powerful rotating cylinders equipped with sharp blades scrape the inner surface of the hide. As the hide passes through the rollers, the blades remove excess fat and tissue while leaving the strong collagen layer intact. This step is critical because leftover organic tissue can cause decomposition, unpleasant odors, or uneven tanning later in the process. The removed material is collected separately and often sent to other industries where it may be processed into byproducts such as animal feed ingredients or industrial fats. Once the fleshing stage is complete, the hides move on to another precision operation known as slitting. Natural hides vary significantly in thickness depending on the animal and the body area where the skin originated. However, high-quality leather production requires a uniform thick. With a hide now cleaned, fleshed, and precisely slit, it is ready for the stage that truly defines leather production: tanning. Without tanning, animal skin would quickly decay and harden as it dries. The purpose of tanning is to stabilize the hide's natural collagen fibers so the material becomes durable, flexible, and resistant to decomposition. In most modern tanneries, this transformation is achieved through a method known as chrome tanning. The process begins in a chemical preparation area where technicians mix a solution containing chromium salts, most commonly basic chromium sulfate, with water and other carefully controlled additives. The prepared hides are then loaded into massive rotating tanning drums. Inside these drums, the hides tumble slowly while submerged in the chromium solution. This constant movement ensures that the tanning chemicals penetrate evenly through every layer of the hide. At the microscopic level, an important chemical reaction begins. The chromium ions form strong bonds with the collagen fibers that make up the structure of the skin. These bonds stabilize the fibers, preventing them from sticking together as the hide dries and protecting them from bacterial breakdown. As the reaction progresses, the once fragile hide begins to transform into a much more stable material. One visible sign of this change is the color shift that occurs during the process. The treated material develops a distinct bluish tone, which is why leather at this stage is commonly known as wet blue. This stage can take several hours, depending on the thickness of the hides and the specific leather qualities being produced. Once the tanning process is complete, the hides are removed from the drums and carefully inspected. Although the material now has the durability of leather, it is still wet, thick, and unfinished. Further processing is required to dry the leather, soften it, and add color. In the next stage, the leather will undergo drying and dyeing, where it begins to develop the texture, flexibility, and rich colors used in finished leather products. After the tanning process is complete, the material has officially become leather. However, at this stage, the leather is still saturated with water and chemicals. To prepare it for shaping and finishing, the excess moisture must first be removed. The process begins with powerful squeezing machines. These machines use heavy rollers to press the leather sheets, forcing out large amounts of trapped water. This step not only reduces moisture, but also helps flatten the material for the next stages of processing. From there, the leather moves into specialized drying systems. Some tanneries use heated vacuum drying tables, while others rely on large drying chambers where warm air circulates around the hanging hides. The goal is to remove moisture gradually without damaging the collagen structure that gives leather its strength. Once the leather reaches the correct moisture level, it enters the dyeing stage. With a hide now clean,